Hello guys, my name is Engineer Holiday. We want to look at the definition of a function. What does it mean when we say a function is defined? And when you are given a function, how do you know the element and the image of this function? Now, first of all, let us see how a function can be defined. Now, a function is defined when all values gives a real number of the function. What does that mean? See, a function is defined when all values gives a real what? Number of the function. What I'm trying to say is that, for instance, let's take, don't forget that, recall in our last class that y is equal to f of x, which is a dependent variable. Is a what? A dependent variable. And it represents the set of what? Of image. That means the set of the what? The range. Let me put it that way. It represents the set of range of a particular element called x. Now, we have x as what? And x as the what? The domain. Domain, which is of a function, which are what? Are values of what? Of what? X. Values of argument. Values of argument x. Value of argument x. That means that what? And they represent the every values of what? Of x. And the range are values of what? Okay? Of y that are assumed. Because we have to assume a value. We have to give this function x a value. So the word, a domain of a function is, or are, the domain of a functions are values of argument of x that are assumed, or a range are values of what? Of y that are also what? Assumed. So that means that any value of x that you get in a question represent the domain, while every values of y that you obtain represent the what? The range. Most of the times, the range are always the image of what? Of the element x. The element x represents is from the domain, while the image is the what? Of the element x is from the y axis, or from the y variables. So in this case now, that is, if you are solving for range, you are actually looking for the values of y, and if you are solving for domain, you are looking for the values of x. Now, another thing again is that when you are given a function, the question is that how do you determine, or under which conditions can a function be defined? Because that's very important. Sometimes they give you a function to assume, to analyze, and they will tell you find the value of x, find the values of y for which the function is defined. You know, in the last class we talked about a function as a relation of two sets, or between two sets, x, which is the domain, and y, which is the codomain. And that codomain x must take one and only one word values on the y, which is the codomain. It must not be more than one, only one. So that means that what? A function can really be defined as what? As a relation between what? Two sets, x, which is assumed the what? The domain, or which is the domain, and will be mapped or will be related to the one to or to one and only one members or image in the codomain. So if an element in Y or in the X is taking two of the element Y, which is the codomain, therefore it's not a function. And we also say that in our last class that the function must be defined, and that's what we want to work on now. So how can a function be what? Defined? That we say the function is defined when all values given to the what? To the function is a real number of that function. So now if I give you a value f of x to be equal to what? G of x. Now where f of x is a function that is defined. Now this function f of x is what? The defined what? If or when what? G of x would have, or let me just put it this way. Now if this is a function given to us and the function must be defined in form of this. So G of x is what? Is a polynomial function. Let me put it that way. Is defined. So and what? G of x is a polynomial what? Function. Now, if G of x is a polynomial function, I'm probably they now say f function of x is defined. Therefore, G of x is what? Is defined for what? All real number. Or f of x is defined for all real number. Look at what I'm saying there. If I give you f of x to be equal to what? X squared plus 2x plus 4. See, find what? The function, the value of f of x upon which this particular equation is defined. If this function must be defined, it means that x represents what? X can take any number at all. In as much that number is a real number, is defined. X can take 100, X can take 50, X can take -2, it can take -1 million, -400, -10, it can take any value. So that means that the function f is defined under what? Defined under a real number. Starting from what? Or that ranges or ranges that have its range from what? Minus infinity to what? To plus infinity. So that is to say that if the function f of x is given as g of x and g of x is a polynomial function, it means that f of x is defined for all real number. That is its language, all real number. And what are all real numbers? Starting from minus infinity to plus infinity. It can be linear functions. It can also be what? Quadratic function, which is what we are. It can be power of 3. Degree 1 polynomial is linear. Degree 2 polynomial is quadratic. And we can have degree 3, degree 4, degree 5, and all that. So when I mean polynomial function, it does not eliminate a linear, or it does not remove linear function. So, and when we give an example, for instance, x squared plus 2x plus 4. So f of x is defined under a real number. Well, is defined for, let me see, for all what? For all real number that have its range from where? Minus infinity to what? To plus infinity. That's what now. That is case 1. Let's call this case 1. Now case 2. When can we say a function? Let's say if you have a function like this, square root of what? G of x is given to us. Now we are given a function like this that we say, and is what is defined, this function will be defined when g of x is greater or equal to what? 0. So anything that this particular f of x is defined for a square root of a function like this is defined when g of x is greater or equal to 0. For instance, if I give you f of x equal to what? Square root of what? X minus 2. In this case now, this function is defined when what? X minus 2 is greater than or equal to 0. It cannot be less than 0. It can be equal to 0. If it's less than 0, do you know the implication? Imagine we have square root of minus 16. This one will give us an imaginary number, an undefined number. That's what you're going to give us, because minus 16 is less than 0. So anything g of x here, you must avoid anything less than 0. You must either take equal to 0 or greater than 0. So that means g of x can take what? Equal to 0 or greater than 0 for f of x to be defined. So for f of x to be defined, it means that g of x must be greater or equal to 0. So if I want to solve this question now, I must ensure that x minus 2 inside the square root should be greater than or equal to 0. That is case 2. Now let us look at case 3. Case 3 of what? Of a function. If we are given a function like this, for example, let's say we are given h of x over g of x. So as a radical function, or rational function rather. Rational function. Case 3 now. Now in this case now, what f of x in this case is defined if what? G of x is not equal to 0. So this f of x is defined if g of x is not equal to 0. So you must avoid the denominator to be equal to 0. If not, it will give you what? An undefined. Whether the denominator is polynomial, whether it's linear, whether it's quadratic, any function given to us here, provided is given to us, like you must avoid 0 or at the denominator, because anything divided by 0 will be undefined. Imagine 2 divided by 0, whatever value, this one does not count here. Whatever equation given to us here, provided it's not radical equation, it must be what? That means this denominator will make everything to be what? Undefined. So if it's undefined now, it will what? It will not be a function any longer, because a function must be defined. Case 4 is case 3. Case 4. Now, if you have a function like this, f of s given as what? Let's say we are giving h of x over square root of g of x, like this. Now, what do? This function is defined when what? G of s is greater than 0. It should not be equal to, it should be greater than 0 because of this. You know, when the root was what? At the numerator. If the root is at the numerator, you can say greater or equal to 0. But since it's at the denominator, you must avoid 0. You must avoid 0. So as such, it took away anything that is less than 0 or equal to 0 cannot be assumed in this place. If not, it would disqualify the word undefined. It will now make the function to be undefined. For instance, if I give you f of x is equals to what? 2x plus 1 divided by square root of x minus 2. So this function is what? Undefined. If the denominator, the root at the denominator, the function inside the root is equal to 0 or it is less than 0. but it will be defined when it is greater than 0. So that means x minus 2 must be greater than 0. That's what we are saying for that case 3, I mean case 4. Now let's go to case 5. Case 5, we are done with all the cases, but I think the major cases are now relating to all the other cases as the case may be. It's related to other cases as the case may be. So we want to look at case what? 5. Now case 5, let's say we have case 5. Let's say we have roots of g of s over h of g of s. Let me put h up and put g of s. Square root also. Then we have f of x there. Now, in this case, how can this function be defined? The above function is defined when what? 1. When g of x is greater than 0. That's number 1. That's not all. Then when h of x is greater than or equal to 0. You see now? So this particular one here, let me clear this part so that you will not mix it up. Now this particular one now, we say the function is what? This f of x is defined given like this. Now in this case we have square root and the numerator, we have square root and the denominator. So for this particular function to be defined, we have to consider both the numerator and the denominator. We must ensure that for us to have achieved a function to be defined, you must avoid 0 at the denominator, and the only way to do that is to make your g of x to be greater than 0. Then another thing again to avoid, to make the function defined, is to make the g or h of s to be greater than or equal to 0. It can never be less. It can be 0. Yes, for the fact that we have 0 at the numerator does not make a function undefined. Yes, it's only when we have 0 at the denominator that make a function undefined. So in this case now, we can have a what? A case of this kind. And let me see if I can still give you one more case. Now, we have looked at different cases. We have looked at rational cases. We have looked at polynomial cases. We have looked at square root of a function cases. And let us see if I give you what? F of s equal to what? Let's say it 1 over square root of g of x. Now the question you are going to ask, what is the condition? It's an assignment. You type in the, what is the condition for the function in case 6 to be defined? So that is one of the questions I want to ask you. What is the condition for the function in cases to be defined? That is this case. If you are giving f of s equals 1 over square root of what? G of s. What will make this function to be defined? Now don't forget, everything we have given you here still bounce back to what? If they are not, if this one is not equal to 0, that means if it's not greater than 0, that means the opposite will be undefined. Please don't forget, the opposite of defined is undefined. So if you say a function is defined, then the other opposite should be what? Undefined. So in case they ask, okay, fine, I don't need to do the undefined for you. If a function is what? Is defined under this rational function, that means when the denominator is not equal to 0. Then when it is equal to 0, it's undefined. You should know that. If this one is equal to 0, it means that it is undefined. So I don't need to explain too much to explain myself concerning the different cases that we have talked about. So if any case that you have in mind is not discussed here, you can type it in the comment section. Let's see. So that in the next class, what I'm going to do now is to do what they call analysis and interpretation. Because some people don't know now is that having known all these things, you still need to know how to interpret. For example, if I give you what? Let's say 2,3. If I give you 2,3, for instance, this one is an open bracket. In function, we can interpret as what? 2 what? Less than s, less than 3, meaning that, or let me put 4 there, meaning that the interval, this is an open bracket. This is what? Half closed. Half closed. If I give you 2,4, it means that it's 2 less than s, less than equal to what? 4 is 4. So if I give you close like this, for example, 2,4, it means that this one now means that what? I want to have 2 less than s. This is closed on both sides. Less than s, less than equal to what? 4. But if I give you something like this now, for example, I give you open, close, open, close at 1, and what? Half open. Like this. How do we interpret this one? This one is saying just 2 less than equal to x less than 4. That's how to interpret it. And you cannot close infinity. It's not possible. You cannot have something like this. This is mathematical tautology to have something like this. It's not possible. It's not possible. So that means you are always allowed to open what? Infinity. Because it does not, it continues. It continues. And when you are giving something like this, if I give you something like this, it means that 2 and 4 are not included. This is what? Open bracket. This one is what we call half closed bracket. This is what we call what? Closed bracket. And this one is what we call what? Half what? Open bracket. Half what? Open bracket. Bracket. So this one is half open bracket, this closed bracket, this half closed bracket and open bracket. So if I'm giving you something like this now, it means that it does not start from 2, it starts from 3, and 3 is the only element here. If I give something like this, it means that 2 is not included. It starts from where 3 to 4. But if I give you something like this now, it means that the element are what? 2, 3, and 4 itself. This one only include what? Only what? 3 and 4. 2 is not included. Why this interval includes just only 3? We call it singleton, set with only one element. So this one now is what? This one now we can interpret as 2, 3, and 4. Because 4 is not included. You know why? Because it's just less than. Why is 4 included here? Because less than or equal to. This less than or equal to. This less than, so 2 is not included. So this one will just be what? 2 and 3. So you can do that over and over again. So if I give you something like this, for example, I give you something like this, let's say, interpret this one for me. Okay, 1 to infinity. Or let's say 1 to 2, 1 to 4. I'll close it like this. What will be your answer? So I'll open this part, comma, and I'll close this part. Then after you interpret it in interval form, then list all the elements that this will have, 1 to 4. What are the elements that will be qualified based on the kind of bracket? Don't forget the bracket we have here also indicate the kind of bracket that we have here. Is it half open? Is it half closed? Is it closed? Is it what? Half opened, or it is half closed or open bracket? Just indicate. Then interpret it in terms of interval. Then also list the element. I think those one will help us when we are interpreting or when we are interpreting our answer. You need to know bracket and all that. Although that I don't want to discuss this under any topic. because I believe that there are simple things that we should understand. So we can analyze when we are solving question, we are going to use them. But so far, so good. We have been able to what? Explain all the cases that we have from case 1 to what? Case 6. I've given you case 6 to go and work on. So it's for your own case to go and work on this case 6 and see what we are going to do. Then let me give you one other case to work on. If I give you f of x, for instance, I want to test you. Check this one out for me. And we have square root of g of x and h of x. There's something, I give you something like this. Square of f of x is equals to what? Give you something like this. Let me write it here. Give you f of x equal to what? Square root of what? Let me put h of x. Then we have g of x. Class. Let me call this one case 7. And you do it for me. I just raising the case now. Okay, what will be what is the condition for the function f of x to be defined? Now this is another word question. I want to under which condition under which condition can you place this f of x for this function to be defined? That means that, let me give you one of them. One of them is that, no, I don't want to give you anyone, because you have to combine case 1, case 2 that I gave to you, because this is at the numerator. Then you should know when something is at the denominator, what condition do you give to this for this thing to be defined? Because we are looking at the definition of function now, not undefined nature of function. So we are able to achieve something in this class looking at the definition of a function. We have looked at the definition of a function, how function can be what? Really defined. Or how function can be what? Analyzed. Under which condition can a particular function be what? Be defined if you are given a function. I believe you understand and you comprehend what we did in this class. You understand what we do, what we explained so far in this class. Thank you very much for watching. God bless you. Please just subscribe to get more information about this channel. Thank you.